Hello students, in the last class we have discussed about the Laplace transform. Now today in this session we will discuss about the inverse Laplace transform. Now the Laplace transform and inverse Laplace transform, it is just like a differentiation and integration. We know the derivative of sin x, and sin x is cos x, and integration of cos x is sin x. In the same way, the Laplace transform and inverse Laplace transform. Now, what is the definition of Laplace transform? Definition of Laplace transform: if L of f of t is equal to f of s, the Laplace transform of f of t is f of s. We can write this one as f of t is equal to L inverse of f of s. F of t is called inverse Laplace transform of f of s. Now here the L inverse, it is not simply multiplied with f of s. Here L inverse is called inverse Laplace transform operator. L inverse is called as inverse Laplace transform operator. Now we know the basic formulas in the Laplace transform. Now totally we have the 7 formulas L of 1 as 1 by s. Now by using this definition of inverse Laplace transform, we can write as L inverse of 1 by s is equal to 1, or similarly we can write L of e raised to at, Laplace transform of e raised to at. It is 1 divided by s minus a. Now L inverse of 1 divided by s minus a is e raised to at. As I told, it is just like differentiation. If you consider the d by dx of sin x as cos x, differentiation, and integration of cos x dx is sin x. In the same way, the Laplace transform of 1 is 1 by s, and inverse Laplace transform of 1 by s is 1. It is just like differentiation and integration. This is the Laplace transform, whereas this is inverse Laplace transform. Now by using this basic definition of inverse Laplace transform, we have the standard form L of t raised to n. We can write it as n factorial L of t raised to n, L of t raised to n, it is n factorial divided by s raised to n plus 1. We can write it as L inverse of 1 divided by s raised to n plus 1 is t raised to n divided by n factorial. Here this n factorial, it is constant. You have taken outside the inverse Laplace transform operator and we have cross multiplied. Similarly, we have L of sin 80, we know the formula Laplace a divided by s square plus a square. Here also a is constant. If you take outside the operator L inverse of 1 divided by a square, s square plus a square, it is sin 80 divided by a. Similarly, we can write the next formula L of cos 80, s divided by s square plus a square, that is L inverse of s divided by s square plus a square, it is cos 80. Now, if you know the Laplace transform formula, we can easily remember or easily we can write the inverse Laplace transform formulas. Now, similarly, we have the other formulas. Now, L of sin h80 for hyperbolic function, a divided by s square minus a square. We can write this one as L inverse of 1 divided by s square minus a square is equal to sin h80 hyperbolic function divided by a. Similarly, the last one L of cos h80, it is s divided by s square minus a square. We can write L inverse of s divided by s square minus a square, it is cos h80. These are the basic 7 formulas in the Laplace transform. By this one, we can write the inverse Laplace transform, basic inverse Laplace transform formulas. Now, after this, we have we did some of the properties in the Laplace transform. Now, one of them is first shifting property. Again, by using the first shifting property, we have the 5 standard formulas. We have the 5 standard formulas. L of e raised to at t raised to n factorial divided by s minus a whole to the power of n plus 1, L of e raised to at sin bt, it is b divided by s minus a whole square plus b square, L of e raised to at cos bt is s minus a divided by s minus a whole square plus b square. Similarly, for hyperbolic function, L of e raised to at sin h bt, it is b divided by s minus a whole square minus b square, and last one L of e raised to at cos h bt, it is s minus a divided by s minus a whole square minus b square. When the function is multiplied by the exponential function, one of the property, first shifting property. Now, by using first shifting property, we have the 5 standard formulas. Now, from this one, we can write easily the inverse Laplace transform formulas. This is L inverse of 1 divided by s minus a whole to the power of n plus 1 is e raised to at t raised to n divided by n factorial. Similarly, for this one, we can write inverse transform formula, L inverse of 1 divided by s minus a whole square plus b square. It is e raised to a t sin b t divided by b. Third one, L inverse of s minus a divided by s minus a whole square plus b square. It is e raised to a t cos b t. Similarly, we can write the fourth one. What is fourth one? L inverse of 1 divided by s minus a whole square minus b square e raised to a t sin h b t hyperbolic function divided by b. And last one, L inverse of s minus a divided by s minus a whole square minus b square. It is e raised to a t cos h b t. These are the 5 standard formula by using the first shifting property. Totally we have the 7 standard formulas, basic standard formulas in the inverse Laplace transform and 5 in the first shifting property formulas. Now, we will do the examples. We will do the examples to find the inverse Laplace transform for a given function. Now, here only important is you have to remember the basic formulas. Memorization of the formula is very important, and if you know the Laplace transform formula, easily we can write the inverse Laplace transform formulas. Now, we will do the example. First method by using multiplication of t raised to n formula. Then second one by using the partial fractions method, and third one by using the cannulation theorem. Now, we will do the first one. What is the first one? Multiplication of t raised to n formula. Multiplication of t raised to n formula taking n equal to 1. Taking n equal to 1. What is this formula? If L inverse of f of s is f of t, L inverse of f of s is f of t, then L inverse of f of s by using the multiplication of t raised to n formula taking n equal to 1, it is minus 1 by t L inverse of d by ds of f of s. It is minus 1 by t L inverse of d by ds of f of s. By using this formula, we can do the example. Now, here identification is very important when you have to use this formula. When the given function f of s, is logarithmic function, when the given function f of s is logarithmic function, or or tan inverse some functions or cot inverse, then you can use this formula to find the inverse Laplace transform. Yes. Now, if you see the first example, what is find the inverse Laplace transform of the following function. The first one 1 by 2 log of s square plus a square divided by s square plus b square. Then second one log of s plus a by s plus b. Now third one cot inverse of s by a. Now if you see here, nowhere it is mentioned which method or which formula to be used. Now here it is asked just find inverse Laplace transform. If you see the first two example, it is a logarithmic function, log of s square plus a square by s square plus b square, or log of s plus a by s plus b. It is a logarithmic function. If you see the third example, it is cot inverse, that is inverse trigonometric function. Either it should be the tan inverse or cot inverse. Then you can use this formula, multiplication of t raised to n formula by taking n equal to 1. Important is you have to remember this formula, L inverse of f of s equal to minus 1 by t, L inverse of d by ds of f of s. Here easily we can identify the given function is a logarithmic function or tan inverse or cot inverse. Now first for a given function you have to find the derivative. First step you have to find for the given function you have to find the derivative. Then use this formula, you will get in the standard form and apply the corresponding inverse Laplace transform formula. Yes. Now we will do the example one by one. Yes. What is first example? First example, let f of s equal to given function 1 by 2 log of s square plus a square by s square plus b square. This is your given function. Given function is a logarithmic function. First you have to find the derivative. Then d by ds of f of s is equal to 1 by 2 is constant, d by ds of log of s square plus a square by s square plus b square. Differentiating both sides with respect to s. Now here constant 1 by 2 as it is d by ds. Then it is log m by n. Use the laws of logarithm, log m minus log n, log of s square plus a square minus log of s square plus b square. Now easily we can find the derivative 1 by 2 differentiate with respect to x, log differentiation 1 divided by s square plus a square, inner derivative with respect to s, s square differentiation 2s, a square is constant 0 minus, similarly the second term again logarithmic function, log difference 1 divided by s square plus b square, inner derivative with respect to s, s square equal to 2s, b square is constant 0. Now 2 is common, 2 will get cancels, you will get s divided by s square plus a square minus s divided by s square plus b square. Now we got the derivative for the given function. Now you can use the formula. What is the formula? By using multiplication of t raised to n formula by taking n equal to 1. By taking n equal to 1. What is the formula? L inverse of f of s is equal to minus 1 by t. L inverse of, you have to remember the formula. Formula is very important. It is minus 1 by t, L inverse of d by ds of f of s. Now substitute the corresponding values. Now L inverse minus 1 by t, what is L inverse of derivative? We got it, s divided by s square plus a square minus s divided by s square plus b square, d by ds of f of s. This value you have to substitute. Now simplify, this is minus 1 by t. Now what is the first term? L inverse of s divided by s square plus a square. What is cos 80? Here important is you have to memorize the formula. L inverse of s divided by s square plus a square is cos 80 minus second term L inverse of s divided by s square plus b square. Once again it is cos bt, cos bt. Therefore, L inverse of, what is your f of s? 1 by 2 log of s square plus a square by s square plus b square is equal to minus 1 by t into cos 80 minus cos bt. Like this you have to do the examples. When you are using this one, when the given function is logarithmic function, then you have to use this formula, multiplication of t raised to n formula, taking n equal to 1. And also you have to remember the basic standard formulas of inverse Laplace transform, then you will get the required result. This is the first example. Yes, now similarly we will do the second example. What is the second example? Second example. What is f of s equal to log of s plus a by s plus b. Here also the given function is a logarithmic function. Now first here you have to find the derivative for the given function, d by ds of f of s. It is d by ds of log of s plus a by s plus b. Now simplify by using laws of log m by n. Once again it is log of s plus a minus log of s plus b, log m by n, log m minus log n. Now easily we can find the derivative, log x differentiation, it is 1 by x. Therefore we can write 1 divided by s plus a, log of s plus a differentiation, 1 divided by s plus a minus second term log of s plus b, 1 divided by s plus b. This is your derivative of f of s. Now, use the multiplication of t raised to n formula, taking n equal to 1, taking n equal to 1. Now, once again you have to write the formula L inverse of f of s. You must remember the formula, minus 1 by t L inverse of d by ds of f of s. Now, substitute the corresponding values. L inverse of minus 1 by t, L inverse of derivative, it is 1 divided by s plus a minus 1 divided by s plus b. Substitute the value d by ds of f of s. Now, it is minus 1 by t. What is L inverse of 1 divided by s plus a? Once again, by using the basic formula. What is this formula? What is L inverse of 1 divided by s minus a? It is a raised to at only. Now, in place of plus a, in place of here minus a, here it is plus a. Then what will be the first term? L inverse of 1 divided by s plus a. It is e raised to minus at only, e raised to minus at. Similarly, second term, once again by using the same formula, L inverse of 1 divided by s minus a. Now, it is minus e raised to minus bt. Therefore, L inverse of f of s is log of s plus a by s plus b is equal to minus 1 by t into e raised to minus at minus e raised to minus bt. Like this, you have to do the example for a given function which is logarithmic function. Yes, now we will do one example for inverse trigonometric function. Yes, what is the third example? Same type you have to do it, same type. There is no change in the procedure, only function is inverse trigonometric function. What is the third one? Cot inverse s by a, cot inverse s by a. Then find the derivative d by ds of f of s, d by ds of cot inverse s by a. Now, easily we can find the derivative cot inverse x minus 1 divided by 1 plus x square. Therefore, it is minus 1 divided by 1 plus s square by a square into coefficient of s, that is 1 by a. Coefficient of s is 1. Cot inverse x minus 1 divided by 1 plus x square, it is s minus a whole square, that is s by s square by a square into coefficient of s, that is 1 by a. Now, take LCM and a square will come into the numerator, a will get 1a will get cancelled, so you are left with a divided by s square plus a square minus a divided by s square plus a square. Now, use the formula by using multiplication of t raised to n. By taking n equal to 1, L inverse of f of s equal to minus 1 by t L inverse of d by ds of f of s. Now, minus 1 by t, substitute the value, minus a divided by s square plus a square. Now, this is minus 1 by t as it is, minus a you can take it outside, L inverse of 1 divided by s square plus a square. Now, minus into minus it is plus 1 by t into a. Then what is this is once again by using the basic standard formulas, it is sin a t by a only. L inverse of 1 divided by s square plus a square formula is sin a t by a. 1 a will get cancels, you are left with sin a t by t, sin a t by t only. That is, therefore, L inverse of cot inverse s by a is equal to sin a t by t. Like this, you have to do the example by using the multiplication of t raised to n formula by taking n equal to 1. Yes. Now, we will move on to the second method. What is the second method? Second method, as I told, second one is by using the partial fractions method. When you are using this method, partial fractions method, there are two conditions. One of the condition is the degree of the numerator is less than the degree of the denominator, and denominator is product of linear factor or repeated linear factor or quadratic or repeated quadratic. Then you are going to use the partial fractions method. Already you have studied, you have done the example in previous classes, how by using the partial fractions method. In the same way, we will do the example by using the partial fractions method to find its inverse Laplace transform. Now, what is that first one? Find the inverse Laplace transform of the following functions. First one, 2s square minus 6s plus 5 divided by s cube minus 6x square plus 11s minus 6. Second one, 4s by 5 divided by s plus 2 into s minus 1 whole square. Third one, 5s plus 3 divided by s minus 1 s square plus 2s plus 5. All three example, it is slightly different. Now, here also the method is not mentioned, just simply find inverse Laplace transform. Now, which method or which formula to be used? Now, to use the partial fractions method, I told there are two conditions satisfied. First one, the degree of the numerator is less than the degree of the denominator, and denominator must be the product of linear factor or repeated linear factor, quadratic or repeated quadratic. Now, if you consider the first example, now the first example, if you take, it is s2s square minus 6s plus 5 divided by s cube minus 6x square plus 11s minus 6. Or if you consider the second, 4s plus 5 divided by s plus 2 s minus 1 whole square. If you consider the third example, 5s plus 3 divided by s minus 1 s square plus 2s plus 5. Now, you see here the degree of the numerator is 2, degree of the denominator is 3. Degree of the numerator is less than the denominator, and denominator we can factors, you can factorize as a product of linear factor. How you are finding writing in linear factor? It is a cubic equation. Just by use the calculator, you will get the 3 roots. You will get the 3 roots by using the calculator for the cubic equation, s cube minus 6x square plus 11s minus 6 equal to 0. If you consider cubic equation, naturally 3 roots. By using the calculator, you will get 1, 2, 3. Now, so that we can write it as s minus 1, s minus 2, s minus 3 as a product of linear factor. Or if you consider here, what is degree of the numerator is 1, denominator s square into s cube, degree of the numerator is less than the denominator, and denominator is product of linear factor, and this is repeated linear factor. If you consider this one, degree of the numerator is 1, denominator s square into s cube, degree of the numerator is 1, denominator is 3. Degree of the numerator is less than the denominator, and denominator it is linear factor, whereas this is quadratic. It is a product of linear and quadratic, product of linear and repeated linear factor, here totally product of linear factor. So that we can easily identify, you can use the partial fractions method to find its inverse Laplace transform. Yes. Now, we will do the first example. First example, what is your first example? Consider 2s square minus 6s plus 5 divided by s cube minus 6x square plus 11s minus 6. Now, how will write this one? 2s square minus 6s plus 5. As I told, it is a cubic equation. Directly use the calculator, you will get the 3 roots 1, 2, 3. So that we can write denominator as a product of linear factor s minus 1, s minus 2, s minus 3. Now you can use the partial fractions method. Let 2s square minus 6s plus 5 divided by s minus 1, s minus 2, s minus, how you are writing? A divided by s minus 1 plus b divided by s minus 2 plus c divided by s minus 3. Already you have studied partial fraction in the earlier classes. Now, easily we can find the constant values. 2s square minus 6x plus 5 equal to a into s minus 2, s minus 3 plus b into s minus 1, s minus 3, c into s minus 1, s minus 2. By taking LCM and simplifying, you will get this one. Now, you can easily find the constant values. We know it, how to do it. Now, it is a divided by s minus 1, s minus 1 equal to 0, then put s equal to 1, you will get the a value. Just substitute s equal to 1, you will get a value. How to get b value? S minus 1 equal to 0, b divided by s minus 2, s minus 2 equal to 0, then put s equal to 2, you will get the b value. Then c divided by s minus 3, then again s minus 3 equal to 0, then s equal to 3, put s equal to 3, will get the c value. Now easily we can find the constant values. What will get the a value? A value 1 by 2. What is b value? B is minus 1, c is 5 by 2. We got the constant values a, b and c. Just by putting s equal to 1, we got the a value. Putting s equal to 2, we got the b value. Putting s equal to 3, we will get c value. Now substitute the values of a, b, c in this equation. In this equation, what you will get? 2s square minus 6s plus 5 divided by s minus 1, s minus 2, s minus 3 equal to a value 1 by 2 divided by s minus 1, b value minus 1 divided by s minus 2, c value 5 by 2 divided by s minus 3. Then take inverse Laplace transform on both sides. 2s square minus 6s plus 5 divided by s minus 1, s minus 2, s minus 3. Now 1 by 2 is constant, L inverse of 1 divided by s minus 1, plus into minus is minus L inverse of 1 divided by s minus 2. Similarly, the last term plus 5 by 2 is constant, L inverse of 1 divided by s minus 3. What is this one? L inverse of 2s square minus 6s plus 5 divided by what is s cube as given in the problem, s cube minus 6x square plus 11s minus 6, 1 by 2 RHS. What is this is? By using standard formula, L inverse of 1 divided by s minus a. Again you must know the basic standard formulas. L inverse of 1 divided by s minus a, e raised to 80. Therefore, this is e raised to t. A is here 1 minus what is L inverse of 1 divided by s minus 2. L inverse of 1 divided by s minus a is 2 here, e raised to 2t plus 5 by 2. Similarly, L inverse of 1 divided by s minus 3, a is 3 here, e raised to 3t, 5 by 2 e raised to 3t. Just by using the partial fractions, we can able to find the inverse Laplace transform for the given function. Now, we will do the second example. We will do the second example by using the partial fractions method. What is second example? Let 4s plus 5 divided by s plus 2 s minus 1 whole square. Here it is denominator is product of linear factor s plus 2, a divided by s plus 2. Second one is repeated linear factor. How you are going to write? B divided by s minus 1, then it is repeated 2 times, therefore again c divided by s minus 1 whole square. Now as usual you have to find the constant values a, b and c. Take LCM and simplify. What you will get? 4s plus 5 equal to a into s minus 1 whole square plus b into s plus 2 s minus 1 plus c into s plus 2. Now, once again here you have to find the constant values a, b, c. How you are finding the a value? S plus 2 equal to 0, put s equal to minus 2. Then how you are getting b and c value? Put s equal to 1. Which value you are getting? You are getting the c value. C value, okay. Then again to find another value, b, how you are going to find out b value? Just putting s equal to 0. Find the constant values. Find the constant values. A, what you are getting? A value minus 1 by 3. What you are getting? C value? C value is 3. What about B? B is 1 by 3. Now, we got the values of A, B and C. Now, just substitute in the given corresponding values. A is minus 1 by 3 by s plus 2, B value 1 by 3 divided by s minus 1, C value 3 divided by s minus 1 whole square. Now, just take the inverse Laplace transform on both sides. Minus 1 by 3 is constant, L inverse of 1 divided by s plus 2 plus 1 by 3 L inverse of 1 divided by s minus 1. 3 is also constant, L divided by 1 divided by s minus 1 whole square. Now, as I told, you have to remember the formula L inverse of 1 divided by, same formula L inverse of 1 divided by s minus a e raised to a t. Here it is a is minus 2 e raised to minus 2t plus 1 by 3 e raised to t only, again by using same formula L inverse of 1 divided by s minus a e raised to plus 3. What about this one? L inverse of 1 divided by s minus a whole to the power of n plus 1 e raised to a t t raised to n by n factorial. A is here 1 e raised to t into t divided by 1 factorial, it is 1. Like this you have to do the problems by using the partial fractions method. Yes, in the next class we will do one more example where the denominator is product of linear and quadratic. Yes, we will continue in the next class. Thank you.